This is the Boring Climate Podcast, a platform where we encourage serious climate conversations. I'm your host Vishwata, and today we're exploring the importance of biodiversity monitoring to better understand our changing planet. Our guest today is Dr. Kadambari Devarajan, an engineer-turned-ecologist and a NatGeo explorer. She uses her love for tech and data to develop methods to improve biodiversity monitoring and thereby improve its conservation. After her engineering, she did her PhD at the University of Massachusetts at Amherst and her postdoc at the University of Rhode Island. An advocate for open source tech and data and a passionate science communicator, she truly brings a multidisciplinary approach to her work. Welcome to the podcast, Kadambari.
Thanks for having me here, Vishwata.
Yeah. So we'll begin with the multidisciplinary approach. So your work bridges several facets. What made you believe that all of this couldn't be studied in isolation and that an integrated approach would work better?
So some of it was happenstance. I had a background in computer science, and then I started graduate school in computer science again for a PhD. As part of this course, I was spending a lot of time in an ecology professor's lab, just putting taggers on cotton-tailed rabbits and studying coyotes and just having so much fun, and it was my first proper introduction to ecology, and so I just loved it so much. So one semester into the program, I just came back to India, and my partner was very encouraging. He felt he hadn't seen me as passionate about computer science as I was in doing field work. So I took some time out, and then at that point there were only a couple of programs which allowed people without a biology background to get into ecology or to formally study ecology. And so I chose one. I happened to get in, and that just changed my life. So it was basically just trying to get a flavor of for the field, and also trying to understand and get an exposure to different facets of ecology. And after that, I decided, yeah, this is where my heart lies, and it just sort of gradually so happened that I love fieldwork as well, and a lot of the skills I'd accumulated during my computer science program and my background in math and programming just sort of came together almost organically in the research I was developing as part of my master's as well as for my PhD and later on.
So before we get into more details of your work, could you set context for our listeners by talking to us about what questions you seek to answer with your research?
Sure. So I focus primarily on looking at how technology can help conservation. That is, and I do this in a number of ways and at multiple scales. So I look at spatial and temporal, which is across space and time, how species are distributed, different wildlife and biodiversity. And I also look at conserving both species as well as landscapes. So I don't, a lot of ecologists tend to focus on a single species or a single mammal or a reptile or bird, but I tend to have a macroecological view, and I like to study large systems, but I also like to look at them at local scales, and in order to address those questions I do a lot of field work. So I look at them at local scale, say within a national park or within a city or an urban area. You have wildlife everywhere, so any such at a small scale, as well as at more regional scales and even across the globe. So a lot of my research, recent research has been on large data sets from multiple sources. So I obviously cannot go into the field for large global data. So I collaborate a lot, I collaborate widely, and then a lot of them share their data. My sort of tool of choice for collecting and observing wildlife in order to monitor them is trail cameras or camera traps. And so a lot of my collaborators also tend to use trail cameras, and they share their data, and we work together and look at it, and based on the current project or the question I'm trying to answer, then we that determines the scale at which I'm working on. And sometimes I have to go into the field, which I absolutely love. And sometimes it's more of a desk, just looking at data, but it's still traveling vicariously because I have to look up when it's a collaborator's data set. I may not have actually been there, but it's always good to have a sense and feel for the data. So you tend to travel vicariously and learn about all these. Initially, it was more passion for being in the field and getting my boots muddy, but now I sort of grown into enjoying working with this large data, and that gives me a framework, and I feel like I can contribute a lot more to conservation and ask bigger questions, more foundational, fundamental questions when I'm looking at the big picture.
So that actually brings me to my next question. This was about the study of yours that recently came out, very intriguingly titled When the Wild Things Are, which appends a lot of things we think we know about when animals are awake and asleep and when they do the activities they do. And this could have some implications for how we plan our development, how we plan our conservation. So could you tell us a bit more about how you went about collecting the data for this and what were some of the more significant findings of the study?
So the core team of 4 researchers, my primary collaborators, we were trying to understand when animals are active. What's known in the literature or as like common perception, okay, this species is nocturnal, or this is diurnal, or this is active during twilight. All of those was very circumstantial. There was no actual quantitative study that had looked at whether what's known about the different species actually matches with what's happening, and whether this changes with say human related disturbance or with global change, climate change, any of those. So we wanted to, that was the seed of the idea, and we wanted to look at it at a global scale. And so we got on board a lot of collaborators, and on the paper we have over 200 collaborators as authors, and they all from almost 40 countries, and they shared their camera trap data with us. And we had a specific format, and a lot of the core team was involved with the cleaning and the analysis and all of that. And I came on board primarily because of my interdisciplinary background, sort of bridging computer science and data science and and working with ecological data. So and it was such a massive data set, and it's been it was a lot of fun to work with. And the questions we were trying to answer were also very hadn't been asked in so much asked or covered before. And what we were primarily trying to understand was or show was what's known as plasticity, or the ability to adapt and change. So we treated this, when the animals are active, as what's known as a trait. So to see if they're changing and adapting with say climate or with global change, and also with human footprint. So that was one of the factors we were looking at. And our results were surprising because almost half the data or more did not really match with what was known in the literature, what we found. First of all, not a lot was established. It was more mentioned, okay, the species is active, was found active during this time, more as in passing when answering other questions. And so there were certain species, for example, primates are studied a lot. So the data, we had more robust data on certain species and not on others. So the primary result and the most important one is that species are changing and are adapting, and there's a lot more plasticity to when they're active, right. Which is an important discovery because it helps inform conservation plans. Not only is it important to know where they're found, but it's also important to know when they're active so that we can allocate resources, or we can plan development projects which are already there. So any policy implication that revolves around conservation plans for either particular species or or at the landscape level. It's important to know when different species are active. So that was one of the primary reasons that we set out doing the study. And the title, of course, is a reference to the book, the children's book, Where the Wild Things Are by Maurice Sendak. And we just thought it was very apt, and it would probably help have a wider reach, given the importance and the scope of the study itself.
And similar behavior is also noticed among carnivores who that tend to split shifts to share resources and hunting time and space as well. What are some of these insights into their behavior that you have found through your years of research?
Right. So one of my first, for my master's, I was looking at carnivores, not just carnivores, but a lot of species that co-occur or like are found in the same landscape that are similar. So I focused on 4 specific carnivores for my master's work, trying to understand how they were found in the same area. And this was work I'd done in Kutch in Gujarat. So along the India-Pakistan border, and it's a desert region, and it still supports a lot of wildlife, and it was rather understudied in terms of, given that it's a desert, a lot of people associate wildlife with forested areas. So given that it was a desert, it hadn't been studied in depth before. And so, also I was interested, a lot of wildlife researchers tend to focus or specialize on a single species. Right. And that is one way to, like, you dive deep into one and know the animal inside out. But the other approach, and one where we can sort of optimize resources, because studying wildlife and research tends to be a very expensive and as well as time consuming. So in order to optimize that, I felt that it was good to study several species at once, which is sort of what got me into that. And the Kutch was one area where we found 4 different canids, which is the dog family, wild canids. So you have 3 different wild canids rather, and then the domestic dog. So I was trying to understand how feral dogs were interacting with the wild canids, but also, since they were found in this one area, how were they distributing, how were they distributed across both space and time, and to see how they were partitioning, like what you said, split shifts, whether they were partitioning resources. And so that was my master's work. And I did find that in order to coexist, they were partitioning it. It was very complex because there were 4 of them. If it's like in other parts, I've done research in Zambia where I've looked at the entire carnivore guild as well. And you could see that different carnivores, there's almost a hierarchy, which is size based. So the larger carnivore is like the more dominant one, and there's what's known as a landscape of fear. The smaller species, not just for carnivores but even predator prey. In which case, in carnivores it's size based, in predator prey it's more the predator the presence of the predator sort of determines where the prey species is distributed. So there is, when they are active, matters a lot for their distribution. So where they are sort of matches at any particular time based on different scale. It determines where another species, either predator prey or similar 2 different herbivores or any of those, it factors a lot into those sort of almost subconscious decision processes that these animals are making.
Right. Another thing that I found very interesting in your body of work is the global Dale activity project that you've been running for a while. Can you tell us a little bit more about what it is and how it has benefited you and other researchers in the field?
Sure. So the Global Animal Dial Activity Project is the large project that I was under which the Where the Wild Things Are paper has come out. So first of all, we had to come up with a framework, because this kind of analysis hadn't been done, and this is like for this project we basically built a collated or curated a data base, like an enormous data set from all these, from across 40 countries, from over 200 projects. We had to build this data set from scratch to suit the questions we were answering. So that's really important. First of all, in ecology, it's like, what questions are you trying to answer, as in all science, and then which method would be best to answer it, and what do you need to how do you do that? How do you do that kind of analysis? Our primary question was to try and understand, how best to analyze this when species are active, how best to model that, and to come up with a quantitative framework, build this data set which wasn't in existence from across the globe, and try and answer questions like, are species dial activity actually plastic, or is it a fixed trait that, okay, this species is active only at night and that doesn't change irrespective of where it is found. And there's some wide-ranging species which, for example, they anecdotally from our field experience, we knew that that was not true. But nobody had studied this and didn't have at least at this scale, it hadn't been studied. So we first had to build that data set, and then we had to figure out how to, grapple with this monstrous data set. So, and then which methods, what kind of statistics do we have to use, what kind of computational methods do we have to, and in this process, we had to build up and come up with our own methods in some cases. And then also, because it was such a hugely collaborative project, we also had to share this, we also had to find a way to communicate with our collaborators and share, because all of them have this, small investment as part of this bigger. So we had to, they were stakeholders and important stakeholders, and so we had to figure out a way to communicate that, and that's how this consortium became this project. And under that, we had several research targets, and one of them we had to come up with this framework, which the core team did, a quantitative way to analyze this kind of data. And then the second part of it was with the big When the Wild Things Are paper with the rest of the, with all the collaborators.
Right. And this is a open source kind of model, right? As in, it's accessible to any researcher who would want to use the data sets available in it.
Absolutely. So I'm a big proponent of free and open source software. And so all my research, I try to keep it, accessible and make the data available freely and whenever possible. And the good thing is, a lot of research these days tends to be, if you need to get it published, they do have requirements. There are, I mean, I could host it just on a website and then, or something like that. But in this case in particular, because it was such a global project, it made more sense than ever before to have the data available freely. So there were some sort of restrictions based on countries. So there was some data that we couldn't make available. So we had to, for example, actual locations of species, which had to be masked for just the conservation of the species, because there has been a history of misuse of such data. And just in order to protect those were masked in some case, but by and large it's an open data set which is available for use. Anyone can download and use it. Yeah. Right. And a lot of my projects tend to be like that. Software as well. Any software I help develop or any data that I use, I try to make and whatever code possible. And the good thing is you have there's a lot of with version control systems and like GitHub, there are lots of mechanisms in which to collaborate and make or share these more freely. Yeah.
That is actually what I was going to ask you next is, you co-developed something called Vixen.
Right.
And this obviously has come from your engineering background, the contribution. How did that help, design this and build something like this, which would answer something else, a question that is not related to engineering at all?
So I think engineering is I would say my background in engineering has helped me not has given me a different perspective in answering some ecological questions, which a purely biological exposure may not have grounded me for. So with Vixen, the problem is what led to the development of Vixen, and it was co-developed. So a lot of the actual programming was done by my collaborator on that, but I was closely involved with many aspects of the with the development of that software. And how it happened was, for my field study in Kutch at that time, a lot of the methods were focused on looking at studying a single species. And here I was looking at many species at once, which was something I'd been very passionate about from the get-go. So in order to, I had like thousands of videos that I'd collected. I'd set out camera traps. It was intense field work, and I had all this data. And in addition to my focus 4 species that I was looking at, I had like data on all other mammals that were available in the in that landscape as well. And I felt this was like a lot of time, and this happens with many people. If you're setting a camera trap to study tigers, you will get a lot of associated species. You'll get leopards, you'll get dholes, you'll get elephants, you'll get a lot of other species along with it, and all that data gets discarded. So one reason I wanted to study, but the methods weren't available to analyze all of them together. So the focus had always been on one species. So with Vixen, so because it was one species, a lot of times the camera traps would be in the data from the camera traps would be in the form of images. So there was a lot of there was existing software to help look at images and photos to annotate them. Whereas I was looking at videos, because I thought that getting 30-second videos would give me more information on their behavior, and I could get any additional information. It made more sense to me to collect video data. And also at that point, trail cameras with video capability were just starting to come out. So I had this video data and no means of sort of annotating them. So I have thousands of videos, and then I'd have to open them in like this media browser, say some whatever media player I had available, and then I'd have like a spreadsheet separately in order to enter the data, and then I'd have like all these paper data sheets from which I'd be transcribing data. It was just I was like, for each video it was taking enormous amount of time, like 5 minutes per video, and I had like several thousand videos. So I was, that was clearly a problem, and I was on a strict timeline to finish the project. So then it just, since there was nothing available, I felt we'll have to come up with something. And then I roped in my collaborator to help co-develop Vixen. And then that's how Vixen was born. And Vixen, we felt, was one piece of software with which you can view, extract, and annotate. That's the acronym for Vixen. And because I was studying foxes, and Vixen's a female fox. So anyway, so that's how we named the project. And with Vixen, you can do, we can cover multiple media formats, including videos, text, photographs, acoustic data, nice. Like bird calls and other audio files can also be annotated. And so it's, and there was it looked like there was a lot of other researchers were also interested, especially since it covered multiple media formats. So it's again an open source, free and open source software that's available for anyone to use, and it's been growing in popularity for a bit. Right. And there's definitely a use case for it.
And why open source over, say, proprietary software?
So for me, proprietary software just doesn't make sense to me. And so this is like, from the beginning, I've been such an advocate of open source software. where it's not there checks and balances, in that it's you have multiple collaborators, and it's meant to be shared and just openly available. So for me, paying heavy licensing fees for proprietary software is just, it just doesn't make sense. And especially many institutes pay like lakhs and crores in software licenses. And as an independent researcher, or anyone who doesn't have access to the institutional mechanism of support, then they fall back invariably to free and open. So because there's no affording an individual license often. And especially in a field like ecology, it's like it's not known to pay well. And so it just, for me, there's just no other alternative for, and I just can't think of a proprietary, and it's very closed, and that's just against my ethos of just collaborative community, conservation,
Right.
all of that.
Yeah. That also is one of your other core beliefs, and what you work towards is diversity, equity, inclusion, and justice in the field itself. What would you say about the need to build this kind of localized talent and skill, especially in the context of women in STEM, in a country like ours, or in any space where it has been a challenge historically?
Yeah, I think it's yeah, you're right in that that's a cornerstone of everything I do, and something I'm very vocal about as well. And I try to incorporate that in, even from the design stage of any project I take up. And I feel like diversity, it just makes things better. Having a diversity of opinion makes every project better. Otherwise, it just becomes a unilateral window to of one person's research. And science is a collaborative endeavor. But I feel even if I were not in science, I would still be. These are things I'm passionate about. And also with women in particular, and especially in other countries, even outside India, it's women of color are vastly underrepresented in science and in STEM fields. So I feel it's almost like a personal, the personal is the political, right? So for me, it matters a lot to have a more inclusive environment around me, as well as wherever I am. Whether I'm part of a different group, or whether I'm building my own group and my own project, it has to have diverse opinions, and it has to be very accessible, which again plays into my passion for free and open source software tools, any of that data. And environmental justice is something that and is just something that needs to be more in the common agenda and awareness, because it's been stuck in certain pockets, in very in certain cliques for far too long, and it needs to be democratized and just decolonized. So that's a big part of why I or more than why I do what I do, it's more how I do what I do. Yeah.
So your research has definite policy implications in terms of how we plan wildlife areas or how we plan our conservation models. Could you tell us a bit about how what these implications could be?
Right. So, well, some of my research is purely ecological, like I develop tools, but the hope is that there will be policy or conservation implications for at least most of what I do. And so and fundamental research also sometimes ends up having crucial applications later on. So not to rule that out, but I try to from the beginning, when even from designing, try to answer questions that are that have some conservation implications. So there are multiple ways to do this, but a lot of it depends on my research, the questions I'm asking, the stakeholders that are part of that particular project. All of those matter, and in some cases the conservation application is very obvious. So, for example, when I was working in Zambia for a portion of my dissertation, PhD dissertation research, I was working inside a protected area, and nobody had. It was a really remote, tiny little national park on the border with the Democratic Republic of Congo, and nobody had done like a camera trap study, systematic camera trap study there. So there was no idea of even what species were found. There was anecdotal evidence, but no actual photographic evidence of what the community, the mammal community there looked like. So my study helped with that, and it actually ended up with a lot of implications for the protection and the management of that one particular protected area. But I also work outside of protected areas. So, for example, my field work in Kutch was completely not quite entirely out of protected areas, but was in a mosaic of sort of semi-protected as well as just areas with high human use. Landscapes with a lot of nomadic pastoralists and villages. And so, and a big part of conservation, which a lot of people forget, is not just the wildlife, but actually people, and there are 9 billion of us. So it's like people, the human dimensions of conservation are so important. So trying to understand for example, with the Global Animal Dial Activity Project is we looked at human footprint as a proxy to understand how animals are adapting to human presence and to urban areas. And with an increase in urban areas, that is another important aspect. And outside of protected areas, you have a lot of human-wildlife interactions. Some are positive, and some, while others tend to be there's a lot of conflict as well. There are issues like crop raiding, poaching, and a lot of loss on both on either side, both humans as well as wildlife lives lost. So the idea is that my research can somehow help formulate plans or help in the conservation without any further loss of life, and to stop species from going extinct, and just managing landscapes and developing conservation plans to protect as many species at a time, not just one species at a time. And this wouldn't happen if not for my belief that there's so many other amazing researchers who are working on protecting a single species that's on the verge of extinction. And with that, I'm trying to add my bit by trying and looking at a broader picture, more at a landscape level, at community levels, adding my support. And it's a collective endeavor. And so this is just how I feel I can contribute best.
Right. And in terms of technology advancing, specifically for biodiversity monitoring, so say AI in biodiversity monitoring, what are the pros and cons that you see?
Right. So a lot of my research is at the intersection of technology and biodiversity conservation, and especially on using technology for monitoring wildlife. And it's amazing to see how long it's come. I've been working on this for over a decade, and it's amazing to see how far we've come in terms of just the amount of technology that's been available, and the novel and like almost ingenious uses and in the application of technology for conservation, from say drones to trail cameras to acoustic recorders, underwater research equipment, all of that. So technology is everywhere, and a lot of my work wouldn't happen if not for remote sensed data and like satellites and all of that. So in particular with AI, it's a double-edged sword, AI. So there's a lot that can lot of good that can happen, in the sense that even with my 7,000 or several thousand videos data from studying the carnivores, it's like I had to sit and manually enter and annotate all of that data. And there are machine learning and AI approaches that can make things like that a lot easier. And especially with a lot of community science and citizen science providing so much data, AI will certainly help in simplifying analysis, and there are ways to deal with it. But like I said, AI is a double-edged sword. So there are several ways in which AI can be misused, but not just AI. A lot of data, and there's been an erosion in the trust in science, just from the number of retractions that have happened, not due to accidental accidents, which are normal and needs to be normalized if it was an incidental mistake that was one off, but deliberate sort of misuse or fudging of data, just that is a big no-no, and that's a huge problem in science these days. But that said, technology has just advanced in leaps and bounds, and we have such amazing ways of collecting data these days, that sometimes the ways to analyze data are still catching up. So we have all these novel methods, and which are fantastic, but that said, we're still catching up with how fast and furiously the technology is advancing. But it's a great thing for conservation. On the flip side, I feel like with technology comes a lot of other conservation issues. Like every time I'd set up cameras, each camera would take 8 batteries, and I would not be able to either have no electricity, so I can't use rechargeable batteries, and all of these. So if I have an array of 100 cameras, then that's like for each cycle I'm running through 800 batteries. So it's just, and the sheer enormity in this age of just disposal and the impacts on the environment, it would make me enormously guilty. So there are a lot of advances to make even how we do research and the application of technology more sustainable and with a lower footprint than it currently is at. So I think that's something that I think really needs to we need to think and have our thinking hats on and try and focus and intentionally work towards minimizing how scientists are doing research, so that we have so that is another angle in which conservation needs to happen.
Right, and finally we'll get to you being a passionate science communicator, and you simplify your research. You even sometimes use narrative arcs to make it more accessible to people. But does that put you in a spot where you end up needing to convince scientists that this is serious work?
I think a lot of scientists these days are realizing the value of science communication and making their research more accessible to the public. So I think the days of having dense, hard to pass literature, or even as teachers, that it needs to be what you do needs to reach. Like, publications are one way of sharing what you do, right, and that's for a focus, like a niche audience of other peers and other researchers. But also, especially in a field like conservation, it's very important to to appeal to as wide an audience as we can, from policymakers to like when I do field work, I try and attend like village meetings and public. They'll usually have like a monthly meeting or something, and I would make sure that I show what I've been doing it's on their land. I'm an outsider who's come from this fancy city, and then I'm on doing it on. I have to ensure that I'm doing it on their terms, and I may or may not agree with some of their values and what they've been doing, but I still have to be respectful, and I owe it to them that I'm working on their land. So not just to get permission for the work I do, but also for sharing with them what they may know. They know their land inside out, but there's still aspects that they may not know, maybe because of when an animal is active. And these are things that I would invariably get. They would just be so happy to see, oh, this was found like in this area that I already knew, right in my backyard. So things like that, from that scale to like a global scale, and to public in the media, where like a lot of the When the Wild Things Are paper has been receiving a lot of media and press coverage. And so it's so I have other people in multiple countries who are also finding out. So from the small scale to a global level, I'd like to, it'll be nice for conservation, especially just in terms of awareness, and my research making that slight nudge into, say, conserving one species or a landscape, or making a difference to one person, any of that. So which is where science communication is so important. And in order to make it more accessible, you have to keep it engaging. If, dry language that's like in an old textbook at the school level, gone are those days. And there's so much, and they're just so amazing. It just, what the kind of research I do, the animals, and being in the field, there's just so many stories. It's easy for me to sort of tap into that, and just, or there's so many adventures in doing field work, or in the process of doing research, that it makes it easy for me to communicate that. And that's just, I just love sharing that, and just enjoy the process. So even with whether it's writing or speaking, or whatever project I take up, I try to, and with the global project, one way was to have a website where we could share it with the other collaborators, so they can see and interact with how their data fits into this bigger picture. So it's partly a responsibility that I sort of taken upon myself, that I need to communicate this to whoever the stakeholder is in that project, or also the communities I'm working in and working with. I owe it to all of them. So that's another reason that I like, and I really enjoy it. I truly do. It helps me. It helps keep the creative juices flowing.
Right. And what are you now working on? What future projects are on the cards?
So I just finished the big collaborative paper, which was a huge undertaking. And then my next project, while doing that, I had some personal life projects, including the next generation that's of explorers and conservationists coming in. So I was on maternity leave for a little bit, but I'm currently working on my favorite project yet, which is a book. I'm looking at, it's a nonfiction book that I've been working on. It should hopefully be published, if my editor is okay with it, in the next year or so. And it's tying very local backyard trees with larger conservation themes, is the sort of the summary of it. So that's what I've been working on. And in the process, I've been looking at, it's nonfiction, and I've been looking at folk tales and mythology and history, popular science. So it'll have, and partly like a memoir. So it combines a lot of these. So there's a little bit of science, conservation, just stories and mythology from different countries, from within India, different parts of India, different languages, history, a little masala from all of these mix of spices. Yeah.
Interesting stuff. Yeah. Thank you so much for this wonderful conversation and for allowing us to vicariously travel with you to all of these landscapes that you visited. It was truly a pleasure having you on the show.
Thanks, Vishwada. This was, I really enjoyed talking with you, and thanks for putting together such thoughtful questions to get me to talk.
Yes. If you like this podcast, subscribe to us on YouTube or wherever else you get your podcast.